Oh, dear ladies and gentlemen, Maria, welcome. Anyway, thank you very much. I am really happy to be here. Even this pandemic period, we really wanted to be here because I'm here with my friend Emil Jakabos, who is one of the leaders of our Romanian association. And let's say it could be an open discussion, being only for attendance is here. But anyway, important is to keep the contacts. And our goal was to keep the contact between KGA and the Romanian Association of Building Services Engineer. And how you know, Maria is involved in that, like part of the task force we opened in the REHVA. This task force, because building information modeling, it's a concept which look in the future, but we are nearly this future, and we should improve and we should promote this idea. First of all, before to start, it's more than 20 years that I come in Belgrade, and I really appreciate that together with our Serbian colleagues, we did a lot of work together, and we promote our profession. And it's a task which should be keep and to promote the young generation in our field, because together with Professor Todorovic and with Professor Florea Chiriac, we opened the Danube chapter in 8th of April 2005. I find the diploma which declared chartered our Danube, and I have with me. I can present. Maybe in the evening and the dinner, it could be more interesting to speak about that. Come back in my presentation. The scope of the potential guidebook on BIM is what is the most trending topic of discussion, burning issue of BIM technology, like example, BIM interoperability, BIM skills. Another scope is what kind of information would be useful for HVAC engineers that are currently using or want to use in the future BIM. The third scope is how to outcome a task force of the task force could contribute to higher adoption of BIM amongst HVAC engineers. In fact, the architects and the structural engineers are more developed in this field. But we, because the real life impose, we should come near them and to promote this concept. I can tell you that it's more than 4 years when in my company in the design office we start to use BIM. In fact, it's a first step using the Revit design in 3D. It's very important to understand. Use it Revit. It's not a BIM, because BIM it's a concept more elevate. I want to speak about building information modeling. About the BIM task force guideline for HVAC professional and an introduction in ISO 19650 BIM standards. The BIM task force related with introduction. There are some ideas which we discuss in the task force in our meetings, and in fact it's an open for all professionals who want to be near us and to develop a BIM concept for the HVAC engineers. This is the task. And finally, in REHVA, in this group developed a guidebook, and we want to have a guidebook related with that. The task force will focus on providing common principles to support HVAC professionals when implementing building information modeling in their project and works. Building information modeling is a new approach in design, construction and operation of a building that, unlike traditional practice, allows to extensive and complex management of data and related information. BIM has the potential of increasing the level of coordination and collaboration between the members of all teams involved in a project, architects, engineers, constructors, clients, throughout the entire process, design, technical project, specific details, construction, maintenance. Coordination and collaboration refer both to the level of communication between people and to the exchange of data between the specialized software programs they use. Another important issue, although BIM is increasingly used at international level, there are still many barriers and challenges with the implementation. Different study and research made on BIM identify the following of the most significant issues associated with BIM adoption. An important issue is training of employees. The second, it's management of data. The third, it's the interoperability of the software. Very important. Because the architects use a different software, the structural engineer a different software, and the HVAC engineers different softwares, which imposed to have a connection, an interoperability between them, and to work at the final goal for the final goal of the building. The fifth one, effect of the rate of payments, very important. And the last one, but not the least, complexity of BIM, more time for high level of details. We want to invite all the specialists to be part of the BIM survey and to identify around Europe what are the needs of the HVAC engineers in this aims. Create finally a guidebook based on the real needs of the HVAC market. This is the scope and the aims of the guidebook for the professional. Other possible ideas. Test and report about some new BIM technology, software, instrument, platform. Here it's related with the interoperability, which I mentioned before. But the market it's in development, and the market of the software, of the instruments, and the platform are open. The guide for BIM cooperation with other disciplines on the project HVAC point of view. What HVAC needs from the others, when, what format, how detailed, how often there is no live-only model. Simple guide, how to start BIM from HVAC engineers. Hi, Alexander. Create a guide for BIM using when BIM is not a requirement, but the HVAC engineer decide to use BIM for their own efficiency. Model detail guide, clash detection. Here it's very important, the clash detection, because it's easier to have this clash detection in the design period, not on site because the cost is more high if this clash detection we discover on site. Of course, BIM in construction. Find case study all over Europe, where after design, BIM model was really used during construction. If you have such a project, that could be a case study, and we want to introduce in our task, in our guidebook. And it's important to define the status at European level of BIM, how accepted is. If not, what can be the reason, etc. Here I will pass quickly because there are definitions related with BIM and there are concepts defined in the standards. But it's important for the people who use BIM to know because the interoperability, the collaboration between different professionals are easier if we know the concept and we are familiar with the vocabulary in these topics. Let's say BIM, it's a modern approach to digital information management adopted by the construction sector to increase efficiency and quality in building and infrastructure project and minimize financial losses during construction phase. Another definition could be begins with the creation of an intelligent 3D model to capture, explore and maintain planning, design, construction and operational data in order to better inform decision making for building and infrastructure projects. ISO 294-481 per 1, Building Information Model, Information Delivery Manual, Methodology and Format. This definition we have from them there. Another definition, share digital presentation of physical and functional characteristics of any build object, including buildings, bridges, road, which form a reliable basis for decision. Bim Advantage, better process control, more efficient design and construction times, less design and construction error, less failure costs. Only way to manage complex construction projects. A better cooperation, faster exchange of clear data, better communication with customer and partners. And another advantage is commercial advantage, very important, new services, products for customers, and better communication with customers, user, local residents. BIM Advantage, according to CPM Consulting, it's translated in 20% reduction of build cost, 30% reduction of cost over the lifetime of the building, 30% to 40% reduction in risk, better predictability and of outcomes. Between 40% to 60% increase in the overall project quality, and between 45 to 65% reduction in conflict and rework during construction. It's here very important for the people who work on site. It's an important issue. Who are the BIM actors and the information user? The BIM start with the concept. The architects are the architects. After there are structural engineer, HVAC engineers, electrical engineer, construction engineer, facility managers, and owners. Thanks to that, all these actors are links to BIM, and it's an important things. The BIM focus, how the BIM starts, with a program. First of all, it's the program, the conceptual design, the detailed design, the analysis of design. After that, we can deliver documentation for the building. We start the fabrication. Construction 4D and 5Ds. Here, after the 3Ds, which is the design, we think to the cost and how to manage the labor on site. This include a 4D and 5D concept. That means we can have a flow chart how the work should be done. We can manage the money. We can manage the workers on site. That are very important to manage the resource, the financial resource and the human resource. That is the concept 4D and 5D. And construction logistics we can define with BIM and operation and maintenance. It's very important. Thinking to have all this information for the beginning, for the start, for the conception, through the life cycle of buildings and the maintenance. It's very important. Could be an important part for renovation after 30 years or 40 years or 15 years. The building should be renovated, and having all this information for the beginning, it's very important. And BIM can provide this information. The BIM models, design models. It's in architecture, in civil engineering, in structure, in mechanical, plumbing, and electrical. Another model is construction documents model. Architecture, civil engineering, structural, mechanical, plumbing, electrical specification also. The building physics model. Here it's related with energy performance of building and the energy used in the building, the daylighting, how we use the daylighting, it's very, very important. Contractor models. Here for the contractors, it's good to define the models in architecture, in civil engineering, structure, mechanical, plumbing, electrical, shop drawings. It's very important because are the execution part and the material literature and facility management models. There are, in my presentation, there are description of ISO 19650 standards, which it's a group of standards from 1 to 5 who defined for building information, who defined the building information modeling. It's defined the collaborative process for the effective management of information throughout the delivery and operational phase of asset when BIM is being used. I have some remarks for the first two standards. It's important that BIM not only has 3D tools for managing digital information, but also has a new approach to managing project where digital information is being exchanged, including design, procurement, commissioning, and construction. The ISO 19650 Part 1 and Part 2 are orientated towards to design and construction phases of a project and are preliminary intended for use by parts involved in the procurement, design, construction, and or commissioning of build asset, and parts involved in delivering asset management activity, including operation and maintenance. The standards is about good practice throughout the entire project and asset management team. In line with the standards, we would have the following features. Clear definition for the information needed, the quantity and quality of information produced, efficient and effective transfer of information between those involved in each part of the life cycle, and informed and timely decision making. Information management through the life cycle of building. The standard, the part one of the standard describe and define information management across the whole life cycle and asset. The phase A, it's the blue part, the start of delivery phase, transfer of relevant information from asset information model to project information model. The B part, it's progressive development and design intent model in the virtual construction model. And the C, and end of delivery phase, transfer of relevant information from project information model to asset information model. Essential definition for building information modeling. Use of a shared digital representation of a build asset to facilitate design, construction, and operation process to form a reliable basis for decision. BIM execution plan. It's plan that explain how the information management aspect of the appointment will be carried out by the delivery team. A BIM execution plan defines how, why, when, and by whom the information modeling aspect of the contract will be carried out. The use of BIM should be clearly agreed with the client and specified in the contract alongside the needs which fulfill the agreed contractual obligation. It's very important here the position of client to understand and to be ready to pay for that, because that means a cost in the beginning, but finally this cost will be covered with all the advantage which BIM can be done. Level information need. It's very important in function of the stage of project, because it's a framework that defines the extent and granularity of information. One purpose of defining the level of information need is to prevent delivery of too much information. That means, like example, in the beginning, we are in the start of the design process. We don't need detailed information, but related with the HVAC part in the maintenance, it's important to have the technical requirement of each equipment, who are the supplier of the equipments, and in that way we can provide a program for the maintenance, and we can define also how to change the filters, how to change the fence, to check the fence, and different. Having this information, the level of information is 400 to 450, like example, and in function of details, what we want, what we intend to have, depends on the stage of the project. We should define this level of information. Definition of information required and resulting information models. Information requirements. It's a specification of the information to the asset or project supply chain members need to deliver as a part of their work. It's important to define organizational information requirements, asset information requirements, project information requirements, and exchange information requirements. Here are the relations between them, and all it's related with the asset information model and the project information model. Common data environment. The common data environment it's an agreed source of information for any given project or asset for collecting, managing, and disseminating each information container through a managed process. The concept of common data environments refer to three further concepts: workflow, work in progress, or work approved regarding to the status of information. The second one, it's life cycle, work in progress, shared, published, and archived. And the third is a shared and single source of information. Very important, these three concepts. Also, the common data environment should be adopted to allow information to be shared between all parties involved across the asset of life cycle in delivery and operation of build asset. Productivity improved by sharing digital information and thereby improving collaboration between parties. It reduced the need for hard copy of deliverables. It reuse information and it prevents the use of unreliable or obsolete information, thereby reducing financial losses. All the information, data and metadata can be verified in real time. Thanks to that, it's all the information in real time. It is important to consider security and data quality and integrate appropriate protocol in the common data environment. The second part of the standards, it's delivery phase of the assets. It's important because the part 2 explains a set of processes for information delivery in the cycle of design, construction, and handover, including those relating to task, role and responsibility, as well as the identification and assignment of accountable parties for each activity and task. The figure shows a traditional organization for a project: the appointing party, the client, and the appointing party, the consultant or contractor. Information flow from C to B, rather from C to C, and then B to A or B to B, depending on the contract. We have defined appointing party, lead appointing party, and the C is appointing party and variable amount, and different relation between them, which is explained in the second part of the standard. There is also an information delivery process, and we have defined key assessment and needs, invitation to tender, tender responses, appointment, mobilization, collaboration production of information, information model delivery, and project close out and delivery phase. And all this is it's linked in different stage. The A stage is information model progress by subsequent delivery teams for each appointment. The B area, it's activity undertaken per project, which include all the key mentioned before. The C area, it's activity undertaken per appointment. The D area, it's activity undertaken during the procurement stage of each appointment. The A area, It's activity undertaken during the information planning stage of each appointment. And the last one, F area, it's activity undertaken during the information production stage of each appointment. This was my presentation. It's an invitation for all professional engineers in HVAC to be part of the task force, and we hope that in 2 years to have a guidebook for that, special for the HVAC engineers. It's a concept in progress all over in Europe. We have information from UK, from Belgium, from France, from Germany, from Italy. Even in Romania, the standards are approved from 2019. That means it's only a task which should be achieved quickly, because the time costs money, and we should earn money in our profession. Thank you very much for invitation. Thank you being for us, and I hope this presentation being registered could be a support for our colleagues who cannot attend this meeting. Thank you very much, and I wish all of you to succeed this Congress. Thank you.